So today, I have to apologize for one more thing at the beginning. In my build, Nanite is broken. So here I have a Nanite mesh, which is totally Nanite. But instead, what's visible here is a proxy mesh. And if we go to Nanite, there are no triangles. That's because Unreal Engine has moved to requiring shader model 6 for Nanite, to work at all. The problem is shader model compilation, shader model 6 shader compilation crashes in this build. And I reported that to Epic. I'm waiting for answer. I unfortunately already encountered it once. The thing is that shader model 6 is something exclusive to newer graphics cards. It's not supported on my laptop, for example. Hi Mobin, hi Roy. Yeah, so we'll see how it plays out, because it means bumping up the requirements, and I don't know if Epic plans to keep it like that. So basically now it will be on the most modern hardware. Shader Model 6 is something that came with DirectX 12, so not that bad, but at the same time it's quite a bump. My GPU in theory is capable of handling that, but this was some internal error. I can show you how it looked like. Yeah, get it here. I'll take a look. I enable that, and it says ZZZ DXIL 22277 error. Constant values must be in range for operation. It doesn't say which shader it happens in, but I guess it's either temporal upscaling or virtual something. And this is related to new type of operations, which are half bandwidth operations. Now DirectX enable us not to work on 32 bits, but we can have 16 bits variables directly in the hardware, which is very cool for many things, but it just doesn't work here. So I hope this fix will be easy. I'm waiting for it, but I have to apologize with no Nanite today. But we'll return to it once that it's fixed. Okay, so what remains? What remains? Material editor improvements, very nice ones. This is for later. Instances, selectable in editor. This is very cool. This sounds very simple, but it completely changes the way how much you would like to use instancing now. Instancing works perfectly with Nanite. This is a match made in heaven, actually, because Nanite speeds up rendering. Instancing makes just the source stored somewhere, and then you just keep the transforms. Hi Sedokun. And yeah, so instancing being easily editable now in editor makes it basically the default options for many use cases. And geometry script, this is a plugin. I will dedicate one separate stream to it at some point, but I will show you the basics today. We got the remeshing methods for making low poly in Blueprint, which is amazing. This is the unfortunate shader model 6 broken in my build. Of course, DirectX 12. Sorry for the abbreviations. And for later, high quality translucency reflections. This is amazing. I will show it in a second. And order independent transparency. So let's start with this transparency stuff. And maybe I should show you how it looks by default. So let's open another project. Let me just change one thing. I'm gonna revert my changes and show my typical project that I use on streams. And I want to share the files for this one because this is anyway for a custom build, right? So you won't be able to run it. So while I typically share the project files on Patreon, this one won't have them. Okay, and about the Patreon, patreon.com/TechArtAid. It has 3 tiers. And the second one and the last one give you all recordings of every Twitch stream and also project files, so you can download them later. So yeah, I appreciate patrons that are already here. This is the project I typically share on Patreon. So all the previous maps, all the previous experiments from all the streams. And now let's make a very quick glass material. And glass. What? Here you are. Basically, as for glass, you should be using this new model called thin translucency. It's so much better in terms of quality. So take a look. Material domain, shading model. You change to thin translucent. Okay. Hi, Alan. And thanks Red House Games for following, and Middle, and Tony Baloney. So Sadako says this shader model is super expensive. That's a good point. It is, because it's full pass of drawing the lighting as in the PBR, but again, for the single little surface. Red House Games says that I could catch a stream here today. That's a great, thank you. And nice to have you here. Tony Baloney, welcome. And by the way, if you have anything you would like me to try, or if you think something should have changed but wasn't polished enough in 5.0, let me know, because I'm here for you. Okay, so glass, thin translucent, and as Sadako says, it's expensive, so be cautious. Blend mode, translucent, of course. Then you have to go to the bottom, to translucency, and the lighting mode change to surface forward shading. That's this expensive stuff, but it's required for thin translucency. Forward shading, so rendering the whole lighting again, just for the single object of that glass. But it's cool. And we don't enable anything yet. Now look, this is not enough. We need thin translucency material output. And now this changes the meaning. In thin translucency, things work differently. Transmittance color is actually a tint color. Tint color. Okay? Tint color is how the glass colorizes the background. Let's do blue for a while. Base color is the color of any label you may have on the bottle. So for example, we have a texture of a label or scratches or something on top of glass. That's what's your base color. So let's use base color. Let's use, for example, bright, almost white color for now. You will see later what is it about. Oops. Metallic, you don't use it. Specular, don't touch it. Roughness is the combined roughness of both the label and the glass. Let's use, I would just do the glass, so very low. And opacity is where do you have the label, meaning 1, and where do you have the glass, meaning 0. So let me just add a param, I'll call it opacity for now, and use 0. Okay, so this is how you use thin translucence. And take a look, it's just beautiful. It's thicker towards the edges. Of course, the thickness is fake, but still Fresnel based and very nice. So now let me just compile it. Akira Blade asks, what's the advantage of thin translucence? Is it ideal for thin glass? Actually, no. It's even better for thick glass. I don't know where the name comes from, but you will see. Akira Blade says, any translucent material can be tinted. Not exactly. You will see a difference, but thanks for asking. So take a look. This thin translucency stuff. When you have the transmittance color here, if I make this completely black, can you see what's happening? It really totally darkens the background while having specular untouched. Okay, the specular is still there, it just cuts off the background. If it's white, the glass is almost fully translucent. Now I change it to blue. So look at the saturation. Look how nice this color is, how intense. Because typical glass, when you don't use this thin translucency, you can add a tiny amount of refractions to silicon. That's a very good point. IR. One point. Yeah. It will simulate the thickness better. Mm-hmm. As you can see, the shader is heavy because it's compiling so much longer. Oh, now it looks fine with refraction. Very good. 1.5 it should be, I think. For glass, yeah. The refraction is there. Now we can make lower. Refraction is there. Tinting is there. Now the base color, what is it about? So look, if I have opacity 0, it's like that. If I have opacity 1, I'm getting the label covering the entire glass surface. This is my texture, right? I could use a texture there, I just don't have anything handy right now. So if this opacity was a, let's do this, UV checker pattern, or my own checker. Okay, tiling will be, I don't know, 16 by 16, and the result will be opacity multiplied with this. Let's try that. Okay, tiling is too big. 5 by 5. Ah, I should have made it a parameter, it will compile faster. Okay. Yeah, That House Games asks if this is 5.1 from the GitHub. I'm not sure it's technically 5.1, but yeah, it's the latest one, UE5 main from the GitHub. Okay, take a look. Now checkerboard is my opacity. So here is opacity 1, here's opacity 0. And you can see how it changes between, let's say, a paper label on top of a glass and actual glass. Now, if I reduce that, I can mix between them. So having dirt, scratches, that kind of stuff. But take a look, what's happening here on the bottom. The sorting is completely wrong, right? It's broken. So what if we recreated this material in the new build? Let me take these nodes, copy. I'll also need my plugin, Techart Common. Help, where, silicon? In about? It says 5.1.0 UE5, but it doesn't say the Git. It's basically, I downloaded it on 28th June this year, 2022. Okay, take a look. These things here are transparent. However, they look much better, right? Let me find one thing. Where did I have it? Ah, I have it on the stream. Let me find Discord. Stream feedback. Yeah, take a look. So this is how it looks in 5.0 from Epic Games Launcher. The same problem we have actually here, right? With the bottom corner. The bad sorting within the same mesh. That's how translucents work typically. And in the new one, Look at this, very nice. And now I'll open that instance and show you that if I change opacity to 0, it's opacity, sorry, opacity to 0, and now tint color to something more normal, right? It still works. Opacity 1, Z. Okay, so how is it possible? There are two things you can do in the new build. So in project settings, okay, no, first I will show you the simpler thing. Simpler thing is selecting an object, going into its details, and searching for sort. In advanced, in the lighting section, you have sort triangles, experimental. It's per object. So you have to select an object and enable that sort. And it says enable dynamic sort of meshes triangles to remove ordering issue when rendered with a translucent material. Dynamic, meaning dependent on the view, probably. So if you have multiple objects, you can enable that for both, and it will somehow change something a little. You can try for yourself. However, it doesn't do much in my experience. But this super nice, very good quality sorting comes from another thing. And let me bring back the opacity. So it comes from project settings. And in the project settings, you look for, can't I rescale that? Sorry. You look for order independent. And here you have enable order independent transparency. Enable support for order independent transparency on translucent surfaces, which remove most of the sorting artifacts among translucent surfaces. And it's insanely good at that. It's insanely good. These are glass materials with opacity. They are not opaque meshes and still look perfect. So this thing, this order independent transparency, is based on multi-layered alpha blending. It's a lot of math. It will be heavy. It will be costly. But sometimes you have no choice. For a game, this may be a bad choice performance-wise. But for architecture, just do it. Just enable that. And then I have another thing here. But let me change the settings a little. That's not that. It's just have to come on. Okay. Is it this one? 0. Yeah. Let me do a black tint color. 0. Cool. Look how good these reflections are. They don't have Fresnel, which is kind of bad. But in general, they are sharp, insanely good quality. And I don't use any ray tracing here. And I'll take a look at the 5.0 here. So let me disable the checker. Let me do a darker tint color and see what's going on. Almost nothing is reflected. And here we have the problem, the ordering of triangles within one mesh. It's very problematic in the vanilla Unreal. See, the clouds, the objects, they just barely reflect. You can even see the individual triangles, vertices. You can go here and enable a hack, meaning screen space reflections for a glass. You can do it, sure. HS, yes, this is a new Git build. It's downloaded from GitHub and built manually. Yeah. Okay, so see, discrete space reflections added something somewhere on the edges. But still, if there's nothing to reflect from the screen, you won't be getting many results. Now I'm looking like backwards, right? And the scene is not reflected at all. Of course, it's just reflecting this screen content. On 5.1, kinda, on the Git build, you can go again to engine rendering, go to translucency somewhere. Wait, high reflection. Oh yeah, in Lumen, right. So it's rendering and then the Lumen section. Where's the Lumen? So we have high quality translucency reflection. Whether to use high quality mirror reflections on the front end translucent surfaces increases GPU cost when enabled. So as far as I understand it correctly, let's make the tint color brighter. It works for the first encountered translucent, probably. Which kind of makes sense because here you can see the cloud, right? Can you see it? The cloud reflected in the second mesh. And now when I overlap it, I stop seeing that cloud. It's no longer there. So yeah, as the description said, as the tooltip said, it's for the first layer encountered, the high quality reflection, but they are really high quality, they're super sharp. If I do tint color black, it looks like a normal object, not a translucent. Meanwhile, in 5.0, this is what I'm getting, even with skin space reflections enabled in the material. So these two changes, order independent translucency and high quality reflections, enabled in the project settings of a Git build, they can give you a lot of quality when it comes to architecture visualizations and other stuff that you can really afford using the GPU for such things. In the game, it may be still problematic, and we may rely on the typical problematic translucence, but that's usually a fair compromise. But this, if you can afford it, it just looks great. Okay. Wait a second. Fezer748 asks, did they improve the Lumen metallic reflections? I remember they showing other metallic objects as black. Huh. And Akira asks, do you have proper Lumen reflections on translucent materials in 5.1? In 5.0, they are blurred. So that's the case, exactly. They are blurred in 5.0, and if I enable in project settings this high quality translucency reflections, I'm getting the super sharp, nice reflections for the first layer of a translucent encounter. So not for the things behind it, the first thing closest to the camera. Adam asks, I'm curious as well if they have done something with the shadows. What exactly with the shadows? And Sedokon reminds us that triangle sorting is expensive, so it's generally omitted. So both the sort triangles checkbox here, and even more, the order independent blending in the project settings. Okay, let me hydrate a little. Adam asks if intersecting translucent objects are correct with that method. Let us check. I think they are. They look good. Let's add a checkerboard. So to the opacity, again, curve. Let's just copy the material from here. Oops. As you can see, nodes in the new build are bigger, and I will explain that in a while. Okay, here, timing UV. Cool. Let's save with the checker. Alan says that's a very good intersection. Oh yeah. Improvement on the translucent material shadows. Uh-oh. I don't know if it's a person at all. We'll see. Compilation takes long. I probably need to buy a new Ryzen at some point. I'm running Ryzen 2700X and RTX 2080. Still good, but yeah. Whoa, what the hell? Ah, that's because of the refraction. Refraction 0 for now. Opacity 1. Nothing happened? Ooh. The checkerboard doesn't work? Actually, why? Why doesn't it work? Ah, cool. Great. Okay, so it looks that this order-independent transparency even handles intersection of opacity within the class, which is just amazing. Take a look, opacity 0.6 or 0.3. It just works. It's insanely good. So again, this is project settings in the Git build and order independent transparency. I think disabling that will only refresh when I restart the project. Yeah, unfortunately. Let's not do it, but it works. Okay. Closing that. Shader complexity of that material. And something changed with shader complexity, but I will show it in a second. Details, material. Vertex shader, but where is this full complexity? Platform stats, I think. Compiling. As you can see, I'm using shader model 5 because something's broken with shader model 6 on my build. So pixel shader, stationary surface, or no, dynamic init object, 1781 instructions. I don't know, but let me check because this should be identical in the old one in 5.0. So here also, let's go to Windows, shade platform stats, compiling. Oh, and Adam asks if you can check it without anti-aliasing. Of course, good idea. So let me disable that. Looks stable, I would say. Pretty stable. Yeah, no problems there. These flickering things are the cloud moving. But let's disable real time. No, it's still stable. It's okay. This flickering is lumen, it's not opacity. So yeah, that's good. That's not stochastic, at least not in a visible way. Okay, so for the stats, it was 1607 instructions in 5.0, and it is where 1781 in the new one. So it's a difference of how many? Of around 180 instructions. Yeah. Okay, so that said, let's go back to the material. Let's lower the opacity. Cool. And now let's move to the next thing. Oh, Akira says in the view mode, show shader complexity. View mode, shader complexity. It's there at the very end. Though, by the way, those colors are kind of fake on modern GPUs and on current consoles. It says extremely bad, but honestly, things have changed. Times have changed. GPUs have changed. So these are unrealistic these days. They're just unrealistic. You have to shift that thing. There is a console. There's an option in project settings from the console that you can set what's standard, what's high, and so on. And I recommend moving this a little because this white looks like a panic mode, but just forward shaded glass is expensive like that, and there's nothing you can do about it. And I won't aim just for going fully green for the current console generation. It always says that on the internet you can find the recommended new values for shader complexity for the new console generation. Sounds good. Yeah, Adam says Epic did a very good job with this translucency sorting. That's true. That's true. Oh, Roy says that Asher Zoo posted them probably. Okay, so about materials. Let's go to the material itself and let's discuss the nodes, the node editor improvements. This is the second thing on my list here, or first, inline inputs. So take a look at that. Looks familiar, doesn't it? But then when you create a constant, so hold one, click create a constant, or create constant vector 2, you have two things now. And let me show you the old editor for comparison. Close that. Okay. In the old editor, when I create a constant of scalar, vector 2, vector 3, they look like that. Okay? This is how they look like. And I can drag the vector 3 from here, vector 2. If I wanted just x of this, I would have to do component mask and just take x. Now let me copy these nodes to Unreal Engine from Git. So to the new build. Take a look. The new one, the old one. So the difference is that currently every node that supports vector 3 and vector 2 provides direct component masks. And also you can set its attributes right here without going to the details panel. It snaps the floats very nicely. It doesn't have this, this 001 bullshit. Yeah, that's really, really cool. And you can expand the component mask and select more like this directly in the node itself. But when closed, it looks nice. So now the same with UVs. Text chord, you can select the coordinate index and the tiling directly here. See? I actually missed that they didn't add the red and green here also, but that's a minor thing. That's a really minor thing. So previously you didn't have that, right? Previously if you created UVs, it's just that, and you had to go to the details panel and just change things here. Now you have, oops. Now we have it here, constant coordinate index 1. If I try to do coordinate index 666 and press enter, it unfortunately allows for that. It shouldn't, because it just won't work. Look, if I do 0 and drag, oh, it allows it too. That's bad, because I think the maximum we can use is 7 or 8 or something. But in general, very handy. Now clamp, for example, min and max is here. And I guess, I'm not sure, but let me check in the old one. If I did clamp, yeah, min and max was here as input, but now I can just set it directly if nothing is connected. And standard nodes are standard, and not every node has things exposed. For example, period of time is still only in the details panel. So it's not automatic for every node, but still nice to have. Swizzle node. I know what you mean, Sedacon. So it's only a swizzle function with predefined stuff. But yeah, you mean reordering these. That's true. That's true. That's also handy. If you have a texture sampler, you can now change sampler source to shared wrap directly here. The sampler type, the UVs used. Let me compare with that. If you have texture sampler, yeah, you have only the outputs, but all the rest have to be set on the left. Right? You can hide it. It may be confusing to some, but it shouldn't be because these things were hidden anyway. So it doesn't matter. If you change the sampler, it wasn't visible in any way. Oh, Niagara has a swizzle. Nice. Nice. Let's go back to our list. Instancing in editor. If you go to videos and sort by popularity, you will find my third most popular tutorial ever about instancing. So here I had a field of asteroids, right? Field of asteroids. And there was really a lot of them, and this GPU was GTX 760 with 2 GB of RAM, including recording the video. So this worked insanely well, 120 FPS on the by now ancient GPU. So in this video, I will share a link on the chat. I explained the difference between static mesh and instance. So every single static mesh, if you drop it on a level like that, it contains all these options. So separate physics settings, separate collision settings. The rendering can be different, like cast shadow, don't cast shadow. Light mask, no light mask. Visible, not visible. There's a ton of things. And Unreal drawing objects has to go through every setup like that, every setting like that, and check it and sort them differently, update the scene. That's a lot of work. And also, if you use a different material, if you use a different mesh, it has to reconfigure the global state of the GPU API, meaning that the work will stop, the efficient multi-threading of the GPU will just stop to reconfigure it to draw another object. This is a so-called draw call. Now, in some version of Unreal Engine 4, they added automatic checks if the objects are actually clones, so they try to batch them together into a single draw, which works sometimes, works often. However, if you do manual instancing, you like explicitly say to it, draw it in one go. These are clones, I'm sure. So how does it work? Typically, the most typical use case is to create a blueprint class, actor, dp my instance, drop it, go inside, and in the viewport add not a static mesh component, that's heavy, but hierarchical instanced static mesh. And that's what I show in the video. So you have this instance static mesh, behaves like a normal mesh. You just select something. So sphere, nothing. Nothing is being drawn. Why? Because we have no instances. So let's go to instances, add plus, let's create a single instance. Okay, we have one. Very cool. That's just one mesh. But what can we do more? We can add another instance and change this transform editor, like 200 to the right. It's here. And another one. Minus 200 and 50 to the front. Okay, that's a group. As you can see, very hard to edit, but insanely efficient. And you can also create them in construction script, like grab this, add instance in a for loop, instance transform, you break it again, and for example, no, for each for loop, this will be a prompt variable number or num instances, subtract 1 here, here, and now the transform should be the index multiplied by a variable I will call instance offset x, and it will be a float. By default, it will be 1 meter. Let's grab it. Here is a float now, and this will be my x. That's it. So I'm adding instances procedurally. I'm gonna delete this default ones because I won't need it anymore. Compile. So, okay, nothing here. I'm not sure why. Because number of instances is 0. Okay, so now look. Number of instances 1, 2, 3, 4. And now look, 4,000. It just works. It just draws. But FPS, we dropped it on the level. It just normally works. Nothing bad happens when I look at this object or not. 4,000 spheres. Okay. So now take a look. These are procedural generated, right? But as you can see in this GitHub build of Unreal, I can click it and move them. Here I can't because they are procedural. But what if they weren't? Oh, the size of your world has grown. No. No. What if they weren't procedural? I'm gonna just disable that for now. And yeah, the method itself is very old. I did this tutorial in 2016. It was already there. What's new, and I recommend it really, it's still valid. What's new is handling of that in editor. So let me show you. I will add them manually here again in the instance list. 1, 2, and 3. This one, let's move it by 100. Let's move this one by 200. What has changed in the new build is you can click on that stuff. They are instances, they are not meshes, and just move them and rotate them. And you can save it, go back here, and I'll take a look. This is viewport, instance group. I just click it and move it and rotate it and scale it. And I go back to here in what's the group? Where is it? Oh, here. Select the whole thing. And now if you search for instances, in the mesh, instances, here, they are updated. Look, minus 140. So I take that guy, move it, go back here, it's changed. It's something different. Oh, here. So basically, you can now use instancing and still edit stuff. Now I hope that alt drag would create a new one, but I'm not sure. Okay, created something. Instance group now has 4 members. Okay, let's select the 2 of them. Alt drag 2 of them, scale them. Now select the group, and I have 6 array members. So like normal editing, right? But it's just again a single object, single instancer. Nice. So what's more? What's more is that now I can take an object like that, single object. I just drag and drop actors, heavy static mesh actors, classic stuff. Select those actor, merge actors, batch. And guess what happened? They are hidden. I can just delete them. I don't need them anymore. And what happened is it created a new thing. Where is it? Where are you? Yeah, selecting them is problematic, by the way, because they don't show in the viewport easily, in the outliner easily. Wait a second. I'm just gonna delete those. Okay, it should be easier to find them now. My instance group is here. Chamfer cube, sure. What are chamfer cubes? It's just named actor. Okay. So look, we did actor, merge actors batch, and it converted it into an instance static mesh component with instances here, transforms here, but you can still select them and move them individually. So there is no point in not using instancing now if you have clones of the same stuff. And if you are wondering about randomizing, like what can you do? They are clones, right? No. You can still randomize. Like do material and randomize instances. Use it here. Material here. And now random instance. Per instance random. Let's do typically you will use a gradient, but I don't know if I have any gradient texture. Plugin content is hidden. Settings, show plugin, textures. I just need any texture with colors. I don't have it. Okay, can be the grass, whatever. Sampling, up. And then let's just pick a color by using append. Append command of, for instance, random as x. B will be 12. And let's just sample this nice little texture. It's too similar. I need something different. Okay, and noise will be very welcome. Use it as UVs. So per instance random is something between 0 and 1. Random value per instance. Let's just grab it and take a look. These are my instances, right? Let's compile that. Yep, they have a different color per instance. And now I take it, drag without, create new ones. And they will always have a different color. That's weird. Okay. So don't delete instances. Roy says that lightmap breaks instancing. Yeah, if you have to bake lighting, they are problematic. I think they don't break, but yeah, they are a no-no because there's nothing cloned, there's nothing common if you have a different lightmap per each. And about the draw cost, Nanite solves the draw cost problem a little, but Nanite still loves instancing because instancing tells it directly, these are clones. Use them like clones. And what's better with Nanite is culling. Here, unfortunately, the whole group is either, if you even see a little part of it, the whole thing is rendered. It's a little better with hierarchical instanced static mesh, but not that much. But in general, typically without Nanite, use it for stuff that is together, that's nearby, locally. If you have an instance somewhere and you see even a tiniest part of that instance, the whole group will be rendered. So avoid it for scenarios like that. Just create 2 instance static meshes, static mesh components. But with Nanite, you can use it like that. Nanite does culling internally in a different way by clusters. So it's very, very good for that. So instance static meshes and Nanite or not, much easier to use in Unreal Engine 5.1, let's say, the Git build, GitHub build. Right? I can just click instances, scale them, move them. And it's just a single actor with one instance static mesh component. So on that technology, they also built the packed level instance. When you do, I don't know how to create that. I think you just right click on stuff. Yeah, and go to level. You can see it, of course, but it says create packed level actor. So create packed level actor creates as many instance static meshes as their individual objects. So take a look. I take these 3, and the same batching works in the same way, but without a separate actor. I take these 3 objects, and let's say these 2 objects. Okay. I do actor, merge actors, batch. These are no longer necessary. It created actor, a single actor. The material is here, it's preserved. And inside you can see two instance static mesh components. You can see that one and that one. So one actor, two components, very lightweight. Components are already more lightweight than actors, and instances are like, just transforms, a bunch of transforms. So very much recommended. The harder thing about that workflow is how to unpack it back. I didn't find anything, found anything about that. I think you cannot just break an instance static mesh into individual actors, but maybe you can. Either way, making a tool for that would be very easy. I just didn't found anything pre-made, let's say, to break instances into static meshes. Okay, so that's that. Do you have any questions so far about any new things? And let me look at the document, because I have a geometry script I want to show you, a plugin. Oh, Roy says they had to make a tool for breaking instances back into actors. Okay. It's fairly easy, yeah. Right. Okay. So now geometry script. And let me hydrate before that. Monty asks, what is the difference between level instances and mesh instances? So mesh instances, you mean the instance static mesh? This is one actor. It's a single component. Hide it or show it. And then it has a bunch of instances inside them, meaning just transform of its clone, right? Level instance is something totally different. So level instance is grabbing a bunch of objects, can be even full actors with stuff. They're like a tiny sublevel. So select the stuff, actor. It may crash, by the way, so forgive me if it happens. You right click, level, level, create level instance. You do it. Enter in the menu Z. Okay. It asks where to do it, so let's do my test. Level instance. And let's say level instance test. Okay. Do it, it does something, and then it replaces these actors with a single level instance, meaning you move them together. If you clone them, you clone the whole thing. You can rotate it. This is the same thing. Now, it's grayed out because it's inside the level instance. So level instance is like a sub-level that has its own transform. So now you can do right-click on that. Oh God, screen. Right-click on that, level, edit, grays out everything else. You do your editing. Okay. And then you either discard that or confirm that. So you right click, level, discard, or commit. So I'll do commit. Committed the change. And both have updated. So this is new, this is new. Because they are references to the same level. Okay? They're the same thing. I edited one and all the clones edited as well, because they point to the same file, to the file I just created, level instance test with spheres. So both this one and this one point to the same thing. So level instances are for cloning a group of things, a building, a chest with some, treasure inside that you want to repeat across the world. And they have stuff inside, but it's like a sub-level. It's not directly editable. You have to right-click, level, edit, and begin to edit. And then right-click, level, commit. And as you can see, committed the changes and repeated them in the clones. So that's the difference between instance static meshes and level instances. Adam asks if terrain renders vegetation in a special way. So vegetation uses hierarchical instanced static mesh. I explained it here at some point. Hierarchical, oh god, an advertisement. Hierarchical instanced static mesh groups instances into clusters and hides or shows the entire cluster, depending on the visibility in the camera. So foliage uses this hierarchical instanced static mesh, meaning it doesn't call by camera the individual foliage instance, but still hides a group. So it's quite okay. Quite okay. Yeah, and as Akira says, Akira Blade, mesh instances are the clones of the same mesh. You can just randomize the material. Level instances are a collection of things. The name is misleading because level instances don't use instancing. They're just collections. But what can we do? That's just the name. Roy asks if they finally added nodes for texture bombing, but I'm not sure, sorry, I don't know. Okay, so having this behind us, I'll show you entirely new cool stuff. Edit, plugins, and search for geometry script. Is here. Geometry script provides a library of functions for creating and editing meshes in blueprints and Python. Yes. Enable that, restart the editor, and now. And it adds a couple new things. A few new things in JavaScript. You right click, you create a new blueprint class. It asks what to base it on. So you go to all classes and use generated dynamic mesh actor. You use that. And by the way, we should do a full geometry script stream someday. Yeah. Oh, and one I said there's also a lightweight instance plugin to transform a whole blueprint to instance meshes and transform it back to BP on trace hit results. This is something cool to explore. So look at the name that one I described on the chat. Basically, you have a, let's say, forest of instances, and then on hit with an axe, you convert only one instance dynamically. It breaks it out of the instance group, deletes them, and creates an actor in the same exact place, which can then react to the axe being, cut and fall. So it's for doing stuff with instances and then replacing them with actors when they are needed. Adam asks that they think if hierarchical instanced static mesh was mostly for LOD. For LOD, yes, but also for clustering by distance. Yeah, one eye is keeping fingers crossed for a GeoScript stream. Geometry stream is insane. Geometry script. But let's look. PP, dynamic geo, actor. I bring it here. There's nothing there yet. Okay. And now, take a look. It has a component. It's not a static mesh, it's a dynamic mesh component. It's not construction script. It's an event. So you go to functions, you click override, and override on rebuild generated mesh. That's where you do it. Sorry. And you don't even need to get dynamic mesh because you already have it. Target mesh is here. You just do this, compile. Okay. Yes, it's here. Sorry for that mistake. Okay, some in a very odd place, but it's there. So let's go back to the event graph. So yeah, you have to click on functions and click on rebuild generated mesh, which is here. It's an event. And then you do your stuff. You're getting a target mesh already. Okay, so we copied a single mesh. It's here. If you look in that place, let's move it. It's here, but it's dynamically generated. It doesn't look like much, but you will see in a second what's going on. We go back here to the event graph. We copy this mesh from our mesh source. Now, dynamic mesh, tessellation. Apply uniform tessellation. Whether it's a failure or success, it doesn't matter. Tessellation level 2. And first, before I compile, let's take a look at wireframe. It's here. And now I apply tessellation of level 2 and compile. Much denser, right? Tessellation 0, standard. Tessellation 3, dense. So now I can take this mesh and do purlin. Apply purlin noise to mesh. Options are here, so make these options along normal. Of course, one layer for now, so make that layer, or just split the pin. Magnitude 5, frequency that and that. Let's see. Here it is. Let's apply a more shiny material. Okay. Materials are here. From. Right? So this is without purlin, and this is with. Now everything's changed, but the normals didn't change. They are still unmoved, I think, or are they? Anyway, we can now recompute normals in Blueprint, mind you. Compile. Yeah, now it works. So again, magnitude. Let's do 5. Here they are. This is without normals, and this is with. So that's already an advantage over doing stuff in work position also in the shader. You can recompute the normals, but that's not all. That's not all. So yeah, that's one layer. Let's display the wireframe. Quite dense, right? Now the frequency. What's frequency shift, by the way? Something weird. It's just an offset. Okay. So this is cool, but this is too dense for that need. It definitely is. But I also want to do a displacement by texture. Displace by texture map. I replace parallel with that thing, like here. Yeah. Okay. Now let's select a texture which would be very artificial. So let's say not bricks, but something like a logo. Maybe Unreal logo. Okay. Options. UV scale 3 by 3. Center 0, meaning it will start from the black and only up. Let's try. It displaces Unreal logo. Let's do UV 1.5. Again, Unreal logo is displaced. The mesh is still not dense enough because this texture is very detailed. So let's increase the tessellation level to 5. It would be insane, but see, it's still very fast. It's very fast. I can change the offset, compile. It's like a second or something. Okay, cool. But we don't need that much detail in other places, right? We don't need that much detail here. So what do? We take that mesh before recomputing the loss, and we do, or maybe after, I don't know. We take that mesh and do simplify to tolerance. Okay, simplify to tolerance. And in the tolerance, let's do 0.9 for now. Oh, that's an expensive operation. I should have used less. Right, so now the tolerance is very high, tolerance for errors. So this is an insane error. See? But it's there. It's a dynamic LOD. Not dynamic, but you know, in Blueprint. In Blueprint. So let me reduce the tessellation to 4 to make calculations faster. 4 to 3 for now. And now the tolerance will be 0.1. Compile. Hi Ninja Heart. Yeah, as Akira Blade says, Nanite is also good for low poly. It's basically for opaque stuff, for solid. But anything like that, like non-glass, non-visual effects, Nanite is good there. Oh, it doesn't work on VR. That's bad. So take a look. This is a mesh. Again, this is a mesh after tessellation and displacement, but without simplification, right? And now we add this simplification, compile. Wait a second. And as you can see, it cleaned up all the geo except the bumpy thing. Of course, the tolerance doesn't have to be that harsh. We can do 0.03 and compile. Much better, right? But still optimal. So basically now you can simplify meshes in Blueprint using geometry script. Of course, it's in editor, it's not real time, but still. And what more? That's not the only way. If your mesh, this mesh is actually quite an orderly, good mesh. Let's disable everything, by the way, for now, just to show the original. Yeah, this is the original. It's quite normal, right? But what if you wanted to use a mesh source like a cube? Cube. Take a date rounded cube. It's here. So that's our cube. And how to displace it, right? Tessellation was added, but it doesn't have anything to tessellate. Let's disable simplification for now. Yeah. So this is way too dense, and this is way too sparse to do anything proper. So what to do? instead of using uniform tessellation, use apply uniform remesh. And this is insane. This is like Houdini. Take a look. This is the cube. Now instead I will use uniform remesh. Remesh options. Uniform options. Triangle count 5000. Okay. This is the mesh. See? Difference? This is standard tessellation, so like subdivision. And this is uniform remesh. Okay, I can do 10,000 triangles. Cool. So really uniform triangles based on the shape, on the angularity of the mesh. 30,000. Right? Now, having this, I can already do some proper displacement. I guess. I can't, because it doesn't have UVs. I could do a parallel displacement. Like that. This I can do, because paralleling is procedural, but remeshing with that method loses UVs. So, geoscript UV how to generate patch builder mesh UV sounds cool. Let's try. Let's try. I don't know what it will do, by the way. This is the first time I use it. Okay, uniform remesh options. Oh, that's a lot. I don't know how to preview this UV. So let's apply not a parallel, but this texture map thing. It may take a while. Patch builder meshes. Nebulous asks if there are any temporal super resolution improvements. I'm not sure, to be honest. I don't know. And Sedokun, yes, you can bake normals in geometry script. Actually, you can do it. You can provide a low poly, you can tessellate displays, do all the stuff in Blueprint, configurable by the user. You can even write editor utility widget around the geometry script. Uh-oh. I just broke it. And bye. Yeah, unfortunately. Yes, loaded. So in general, oh, by the way, 32 people on the stream. That's the record. I mean, we had 80 once, but this was a raid. Thank you for being here. And say hello if you're new. And also join our Discord. Is there a Discord link? There is a Discord link. Come here and say hello. And say who are you and why are you interested in that stuff. Because I'm really curious, what are you doing? Okay, so here's our beautiful cube. Let's not recreate UVs in real time because it's broken and it's heavy. But you can with simpler methods. Okay, so uniform remesh. Remesh options. Make. Read project to input mesh. There's a lot. By the way, there is a lot. Prevent normal flips. Smoothing rate. UV preserving. Let's try. Will it really preserve the UVs? So not Perlin, but display mark. Target mesh here. Here. Okay. Compile. I wouldn't say it preserves UVs. Let's try the uniform tessellation instead. And just see. Ah, maybe that's just not the vertices. Yeah, the logo is barely visible, but it's here. Do I simplify? No. Okay, displacement could be stronger, by the way. Magnitude 2. Okay, tessellation works with what density? That density. Okay. So now again the remesh. Yep. Ah, it preserves. Take a look. This option, smoothing type UV preserving, preserves the UVs. Amazing. So I just need more triangles. 90,000. Oh, it's slower now. Okay. Just works. Now, if the texture was blurred a little, it's a bad texture, you know. But it's there, so I don't have to generate this UV. Perfect. So uniform remesh, you create the options and you select UV preserving smoothing type. Perfect. The wireframe looks like this. It's really uniform. It's not too dense on the edges, it's normal on the edges. Okay, so now I only have to apply simplify to tolerance. Come on, come on. Target mesh. And then recompute the normals. Okay, this may be slow, so let's save all. Tolerance 003. Okay, so that's the original wire. Let's compile. It will take it a while. Adam wishes that Nanite worked on low-end devices. Yeah, but also it requires a certain sophistication of the device. You know, compute shaders on a certain level and so on. Programmability. So definitely, but yeah. So we need a low-powered device, but modern. Unfortunately, my quite modern laptop from the previous year with Intel integrated graphics doesn't support Nanite. But that would be a very good target. And yeah, Nanite is good for low poly. It renders low poly even faster than standard. As Akina that says, it's just an automatic way, efficient way to create LODs and manage them. Huh. The simplify to tolerance is very heavy. It really is. Okay, simplified. Take a look, it's beautiful. It has only triangles where it really needs them. The width, okay, not so beautiful, but good enough. And weighted area weighted. So yeah, this simplification remeshing is really well advanced now in the GitHub build of Unreal Engine 5. But generally, even if you're using Epic Launcher build, geometry script is well worth trying. Aldo says ship it. Yeah, for sure. Okay. So I guess that's all I wanted to show you. For those of you who joined later, I have a Patreon, patreon.com/TechRDate. And if you take the middle or the top tier, you will get recording of that full stream. And in the next stream, I hope that Epic will reply me about the Nanite animation mask opacity. Currently shader model 6 is needed for that in the GitHub build, and it breaks on my machine. Thank you so much for being here. There was a big crowd today, really big crowd. And thanks so much for being that active on the chat. Juana says, have a good vacation. Thank you. It starts next week, next Saturday. Okay, so have a good one and bye. Cheers.